Okay, ocean acidification. It's the last topic of 2020, a year that most of us would just like to put behind us. I'm sure that 2021 is going to be a better year for most of us. But let's get on it. Okay, so oceans cover about 70% of the Earth's surface, and seawater, is something that is soluble to CO2. So, in other words, CO2 will dissolve into it, uh, and this is a normal process. It's been going on as long as the oceans have been there. The problem is, you might not be surprised to learn that as we pump just ridiculous amounts of carbon dioxide into the atmosphere, since it is soluble in the water, it moves into the water, and this is causing a problem called ocean acidification. That's a natural process. Okay, so as long as there's been oceans, carbon dioxide has been dissolving into it, and that's a good thing, because that carbon dioxide is basically necessary for phytoplankton to engage in photosynthesis. So we need the carbon dioxide in the ocean. It's a natural part of the system. It's just that we're changing the amount of it, and that's having unintended consequences. So the world oceans hold a lot of carbon dioxide. 38,000 gigatons. That's 38,000 billion tons of carbon dioxide. It's a lot. So that's basically 16 times more carbon contained in the carbon dioxide in the ocean than all the plants and animals on the planet. Okay, 60 times more than the atmosphere had in it before people were here. So really, the ocean is the big repository of carbon dioxide on our planet, and it always has been. And there's a process by which carbon dioxide goes into and out of it called the carbon pump. So what happens is carbon dioxide, like all gases, is more soluble in water when the water is cold and less soluble when the water is warm. So cold water dissolves gases better, be they oxygen or carbon dioxide. When you warm that water up, the gases leave the water. When you cool it down, they enter it at a higher rate. So we typically find is near the poles where the water is cold, so at high latitudes, carbon dioxide moves into the water at a higher rate than it does in the other parts of the ocean. Now, as water gets transported to lower latitudes, toward equatorial and tropical regions, either through upwelling or through surface movement, as the water warms up, the carbon dioxide comes back out of it. So there's this cycle of carbon dioxide into and out of the ocean. And before we mess with it, there was an equilibrium that had been reached. So, in a given year, the same amount of carbon dioxide that went in near the poles came out near the equator, and life was good. Okay. And then we messed with it unintentionally. These are complex systems. That's the thing about environmental science. These are super complex systems, and no wonder people didn't understand them. But now we do, and we really ought to do something about this. So let's look what happens. Okay. Now, in addition to photosynthesis, dissolve, CO2 gets into the ocean. We need it there for photosynthesis. Okay. But another thing that happens is many organisms that live in the ocean, including planktonic organisms, have shells or casts, as they're sometimes called, that are made out of a substance called calcium carbonate. And basically, this calcium carbonate, what a seashell is made out of, right? Uh, when these planktonic organisms die, that they carry that to the bottom. If you were to go in a submersible in the ocean, deep ocean, just look out the window, you'd see this constant rain of particles. Many of those are dead organisms that have calcium carbonate shells, and as those shells come to the bottom, they carry with them a lot of carbon. So, in a sense, these oceanic organisms that have shells are sequestering carbon dioxide for us. All right. And this is a natural phenomenon that's been going on forever, and it's still happening, but we're altering that. Now, look at this. We've looked at this graph before. This is the graph that we talked about at Mauna Loa. This is atmospheric carbon dioxide over the course of the 20th century and into this century. Okay. I just lost my little circle. Darn it. I like that little circle. All right. Now, surprise, surprise, as carbon dioxide level, I got my circle back. As carbon dioxide levels go up, so does the amount of carbon dioxide that's dissolved in the water. I mean, that's not rocket science there, okay? It's kind of cool the way these people did this graph there. If you look, this is atmospheric carbon dioxide in parts per million by volume, and this is the partial pressure of carbon dioxide in microatmospheres. That's whoever did this they had a good idea. I would like to meet that person. Anyway, so we see that as carbon dioxide goes up in the atmosphere, so too does it go up in the oceans. It just makes sense. It's just an equilibrium phenomenon. If there's more gas above putting pressure down in the water, more is going to go into the water. Okay. Well, what is the consequence of this? Well, turns out when carbon dioxide goes into water, it forms a thing called carbonic acid. We talked about this when we talked about acid rain. Like rainwater, even if people didn't put pollutants in the air, if there was no SO2 or NOx, rain is still slightly acidic. It has a low pH. Why? Because carbon dioxide dissolves into water. When it does, it forms C2CO, H2CO3, or carbonic acid, and that causes the pH to go down. Well, so if the oceans are naturally basic, they have a pH that's if it wasn't for this process, it'd probably be up around 9. Okay, but because there is calcium, or rather CO2 dissolving to the ocean, forming carbonic acid, it tends to bring the pH down a little bit lower. Well, what's happened is it's still basic, but lower than it would be without carbon dioxide going to the water. But what's happened is over time, as we've added more and more carbon dioxide to the water, there's more and more carbonic acid in the ocean, so the pH is going down. Now, no, it's still basic, but not as basic as it was historically. So we think that before we started doing this, we were probably up around 8.2, and we're down now around 8. Now, and that's a significant change in the pH of the oceans, at least the surface waters of the ocean. Okay. Now, so when people, and again, these are complex systems. We have these models that try to take everything into account, but it's a hard thing to get. But a lot of scientists say, if we don't do anything by the end of the century, that classic target date of 2100, the ocean's pH could get down to around 7.7, and that's quite a bit of pH change in the oceans. Okay, and that's got some consequences. So we should understand what these consequences are and see if there are things we're okay with, which hopefully we're not. Okay, so remember, one way that this natural system sequesters carbon dioxide is by forming these shells of these organisms in calcium carbonate, which then falls down to the bottom of the ocean, forming limestone sediment. All right, and basically, what happens is when the pH of the water goes up, goes down, when it becomes more acidic, then what happens is it interferes with the ability of these organisms to form shells. So when we do our lab, one thing we're going to look at is the effect of acids on calcium carbonate. What you're going to see is it tends to dissolve calcium carbonate. So uh, basically, uh, these organisms aren't able to form their shells, which isn't good for the organisms, obviously. But here's what happens. So clearly, there's going to be fewer of these organisms around, and that's changing the ecosystem by changing. They're an important food source for many fish. Um, but it also is reducing the rate at which carbon gets sequestered. So whereas the oceans used to be able to take in carbon dioxide and put a bunch of it to the bottom, if these animals can't form their shells, then it can't do that, and so that reduces the rate at which the oceans are able to essentially mitigate the problem. And this is like a real thing. Okay, so like I come from a place called Kitsap County, Washington. We have a body of water which is it's called Hood Canal, but it's not really a canal, and it's connected to Puget Sound, which is a saltwater body of water. It's an embayment, a flooded glacial valley, basically flooded with seawater. Anyway, oysters are a big thing there. Like that's a major industry in my county. I have a good friend. That's what his job is, right? He's an oyster farmer. Well, the problem is ocean acidification has gotten so bad in our area that the spat, or what they call the little baby oyster organisms that are basically zooplankton to start with, they have to be able to start a shell in order to grow. So oysters, they reproduce, they put eggs and sperm in the water. The little babies start. These babies need to form a shell, but it's so acidic they can't form shells. So you're an oyster farmer, you can't form shells. What they have to do is they have to buy already started oysters from other places like Japan. And once they've already got the shell, then they can generate shell material at a faster rate than it dissolves, but only if they get started. So we're already in a point where ocean acidification has impacted the agriculture economy of the place I come from. It's a real phenomenon, and it's having effects in other ways around the world. So I'm just going to try to walk you through this with my lovely artwork. Okay, this is supposed to be a factory. If you couldn't tell, this is supposed to be ocean. I'm kind of proud of my waves. Okay, so here's the idea: we burn fossil fuels, we put carbon dioxide in the atmosphere. But let's be honest, carbon dioxide is in the atmosphere normally. Okay, but we are putting carbon dioxide in the atmosphere. Well, as carbon dioxide builds up, that's pretty cool, isn't it? Okay, as carbon dioxide builds up in the atmosphere, what's going to happen is more and more of it is going to dissolve into the oceans, just like before. But the idea is it's an equilibrium. You put more here, then more goes in here. If there's less here, then this will come out. Okay, now, but we're putting more and more in, so more and more is going into the oceans. Now, what happens is since CO2, when it goes into water, reacts with water to form carbonic acid, the more CO2 we put in the water, the more carbonic acid there is, the lower the pH gets. So even though the ocean started off at about 8.2, it's now down around 8 and it's heading south, right? Because there's just more and more carbon dioxide going to the ocean. Now, uh, remember, ordinarily what would happen is when this carbon dioxide goes in the water, these planktonic organisms, these foraminifera and things like that, coccoliths, they would take this carbon dioxide, make shells, and then die. And then when they die, they would take their carbon dioxide to the bottom and essentially sequester it for millions, tens of millions, hundreds of millions of years. But they can't do that if they can't form shells. So what happens is, as more and more carbon dioxide goes into the ocean, then more and more carbonic acid is formed. Ocean acidification, we call this. That prevents the shelled organisms from forming their shells. So they're no longer performing that ecosystem service of sequestering carbon dioxide for us. So now, whereas carbon dioxide normally would leave the system for a long time by going to the bottom, it's not doing that anymore. It won't do that anymore. It's still doing it, but it's doing it at a slower rate. Okay. And now what's going to happen then is, in addition to the fact that we're taking less, if the shells were forming, we'd be taking these carbon dioxide molecules, bringing them to the ocean, turning them into calcium carbonate, putting them in the bottom. If we're not doing that, then what's going to happen is more and more that's going to build up here. The atmosphere gets warmer. When the atmosphere gets warmer, the ocean gets warmer. Okay, like my thermometer, that took me a while to make. All right. Now, another consequence is this. Remember that carbon dioxide is more soluble when water is cold and less soluble when it's warm. So as the oceans warm, they can take less of this carbon dioxide out of the air. In fact, they'll put some back into it. So essentially, by warming up the oceans, we're reducing its ability to take carbon dioxide out of the air. So it's one of those positive feedback loops, right? So as the temperature goes up, as carbon dioxide goes up, then we reduce the ability to take it out of the air, which makes the temperature go up, which makes more carbon dioxide go in the air, and so on. So that's basically, in a nutshell, what the problem is with ocean acidification. So basically, more carbon dioxide in the oceans, in the air, makes more carbon dioxide in the ocean. More carbon dioxide in the ocean makes more carbonic acid in the ocean. More carbonic acid in the ocean makes it hard for shells to form. And if shells aren't forming, we're not sequestering carbon dioxide. So that leads to more carbon dioxide in the atmosphere. And that leads to higher temperatures. What's the answer? We have to take carbon dioxide out of the air. We have to do this. It's going to be expensive and difficult. And we have to do it. You have to do it. Your generation. So good luck.